Here we go. Lesson 9.5. We are integrating inverse trig. So in the last lesson, that was the rule. What happened?
It's on freeze.
Oh, it's on free. It is recording, but you can't see it through the screen. That's okay. There we go. I'm sorry. But it is recording. So what you see sometimes doesn't mean it's not recorded on the computer. So, the rule for arc sine, right? 1 over. Notice again the hook is in the numerator. What does that remind you of? Integrating. Okay, right? That the hook is in the numerator. In fact, one of the lessons moving on is to be able to distinguish, is that inverse trig question, is that ln question, right? Is that, because some of these are going to look similar, and that you need to be able to identify, no, that's the indicator, right? I know which way to go in terms of that. But I'm going to repeat, like I repeated that lesson, hey, the hook is where? The hook is where? In the numerator. So you can see that. Now, look, when we integrate the other direction, you can see. Now, do you notice here that they don't use arc cosine? That's because sine and cosine, arc sine, arc cosine are the same except for the negative. That if you had a situation with a negative, you could just put the negative in front, and it just would be negative arc cosine, and it would be the same thing. So there's not necessary to do both. But notice for tangent, it is different, right? 1 plus. And where's the hook again? Where's the hook? Where's the hook? Where's the hook? Where's the hook? Okay. And notice that these formulas, we have a 1, right? 1 minus and 1 plus. 1. Now, look underneath. What happens if you have something similar, but it's not 1, but it's a different? A represents another constant, something else squared. Do you see how the rule changes a bit? So it's still arc sine, but what goes inside? It's not u, but u divided by whatever a is. And if you really think about it, a is taking the square root, right, of what we see. We're going to practice this to understand u prime, a, and u and make sure it fits. But this formula, the rule for integrating, when it's not 1 minus or 1 plus, if it's a different constant, and it doesn't have to be a perfect square, it could be a root that's not a perfect square. Inside, you're going to go u over a, and I'm going to try to structure it so you can see u and a and u prime and just fit into the formula and be done that way. All right. It says, note, since the derivative of arc sine and cosine differ only in sign, it is not necessary to have a third integration rule, which I already said, right? So if you have a negative, you can put that negative in front and still be a negative with the arc cosine. All right, differentiate y equals arc sine x over 2. That's your warm-up. Go for it. This is not integrating. Deriving. What's the rule for arc sine? What's the hook? Where does the hook go? So 1/2 could go in the numerator. Now, I'm going to simplify this further. So 1/2 means that 2 could actually go underneath in the denominator. What happened? It is, but what we're setting up here actually is knowing how to integrate. So when we take the derivative, I want you to see how it compares to integration and why we have an a part of it. But I like your thought that don't go more than you have to. And then when I square this, is x squared over 4. We're doing this exercise to compare that to question number 1. Right? We're doing the work for a reason. All right. What would happen, you ready for this? If I want the 2 inside the square root sign. Do you know what you can do algebraically? If I don't want the 2 outside. Do you know how to distribute with a square root? Can I tell you? So inside the square root, it wouldn't be a 2 you would distribute, but it would be a 4. 2 squared is 4. So I can distribute the 2 inside without using 2, but what number would I use instead? 4. So 4 times 1 is 4. And then 4 times a quarter, guess what happens to the 4s? They divide out. And then what do you have when you simplify it? Oh! Shh, I told you. Do you see number 1? Do you see how they match? Well, guess what the answer is? Yeah, right? So, can you see how we're going to work that way? So first of all, we're going to go one step at a time. You know what the answer is because we just did the derivative, right? But of course, when you integrate, you're not going to forget the candy. Good, good. So, can you tell me what A equals here? Look above. This is the rule up here. It's the square root of 4, right? Which is 2. Can you tell me what U equals? It's the square root of x squared, which is x. And what is u prime? Take the derivative of x. If u equals x, u prime equals 1. Now, there might be something where you have to make it look right and then undo it in front of the integration sign, right? So what I'm looking for is this. Is the numerator proper? Is u prime match? Say yes. If it didn't match, you could take the numerator, put it in front, right? Like you can manipulate that constant, right? To make it look right and undo what you did. All right. So if each one of these now, we can follow the rule. This is the rule right here. So what am I going to write down? The answer is arc, I'm following the rule, sine, what's my u? X, what's my a? And the u prime is already embedded, right? So once you have the hook correct, you can follow the rule with u and a, and then don't forget the candy. That's the work today. You're welcome. 2. So one of the indicators is it inverse sine? Is it inverse tangent, the rule look right? Or is it something else like ln, right? That they snuck in there just that you didn't just do it blindly. Got it? So here, look at this. Look at the rule. Look at the denominator. Is the denominator in that form? Which one is it in the form of? By the way, if this was ln, you would take the derivative and you would have to at least have an x on top. Like you take the derivative, it would be 8x, right? It wouldn't have to be 8x because you can manipulate the 8, but it would have to at least have a x. We don't have that, right? It's not ln. This is tangent when you look at it. There are 3 things I'm going to write down. What does a equal? 2x. No. A represents the constant. U represents the variable, but in the denominator you have to take the square root, right? So the square root of 25, the square root of 4x squared, 2x.
A is the constant. A is not going to be the multivariable.
Yeah. And then what's u prime? Using u equals 2x. What's the derivative of 2x?
8x.
What is it?
8x.
The derivative of 2x. We're not going here. That's u squared. So the derivative of 2x is 2. What do you notice in the numerator? Do you see a 2?
No.
I'm going to put a 2 there. Do you see how I just put a 2 there because I'm cool like that? But what does it need to be in front so it's equivalent? I'm listening. What? Why? That's the rule. I'm a rule follower. See up here? The rule for integrating, right? A squared plus u squared. In fact, the integration is 1 plus u squared, right? Where u prime is the hook in front. So if you don't take the square root, you're not getting the hook correct. Because the hook is from u, not u squared, right? The rule for derivatives is squaring. Well, I have to undo that square going backwards and to see the hook. Will you be a rule follower? Yay. Can you see why 1/2 is in front?
Yeah.
Yay. So now that 1/2 is part of the answer. Now what's the rule for arc tangent? What's the rule? Do you see something in front? This is different, right, than sine, arc sine. So it starts with 1 over a. What is our a?
5.
So it starts with 1 over 5. Then it's arctan. And what goes inside arctan? U over A. Our U is over, and then don't forget the done. This is one of those integration rules where you have to be a rule follower and just keep practicing until you remember, okay? Did it get in there?
No.
You missed?
Yeah.
And it's on the ground. The gum is on the ground. What is it? It was in your mouth, it has saliva on it, and it's on the ground. Okay, number 3. I'm listening. The square root of 4x squared. All right, here we go. Listening, 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 listening. Integrating. What I see is this. Shush. 3 plus 4x squared. My head right away thinks tangent. Plus, right? No square root in the bottom. If I take the derivative of this, it would be 8x. There's no x in the numerator. In fact, if it was 8x in the numerator, it would be ln. No x, just 8 means it's going to be arc tangent. Rule follower. You ready? A equals. That's the square root of what? 3. U is the square root of 4x squared. 2x. U prime. 2. Now, I am going to write it correctly. If it was correct, 2 would be in the numerator. The rest are going to write as I see it. How do I make them equivalent? What number do I need in front? Go ahead, Candy.
So the U is the 4x squared.
Square root of the variable. Where do you see the variable?
But if you were to take the square root, wouldn't it cancel out the square?
So no. See, the rule of deriving, differentiating, is that you take it and you square it, right, in the denominator. That part is your U that you're squaring when you take the derivative. So when I go the other direction, to know what my U is, that I squared when I took the derivative, I have to square root it to know what U is. Because the rule for differentiating is to square it. So when you see it, you've already taken the derivative. So I want to undo the derivative. I have to square root to know what U is to undo it. Be a rule follower. Don't be stubborn. All right, here we go. The rule for tangent is 1 over A. That would be 1 over... Oh, what do I need in front first to begin with? So let's start with 4. Then it's 1 over A, which is... And you can leave it. Arc tan. And then inside is U over A, which is 2x over root 3. And don't forget the candy. Number 4. What? You guys are too good. So when you integrate this, see how they threw one in? I gave you a hint. Then that's why. If I didn't give you a hint, you wouldn't figure it out. So anyways, yeah. The derivative of 4x, this is 8x, right? It separates. I don't even have to do anything. This is ln 3 plus 4x squared plus c. Yep. Come on now. Candy bars. 5. You're not going to like me for 5. So, here we go. If I take the derivative, it'd be 8x. 8x squared is too many x's. I can't just pretend it doesn't say. I need x for it to be ln. Next, if it was inverse trig, in fact, it'd be inverse tangent, you'd have to have a constant in the numerator. Not a constant. When the degree on top and the bottom match, you're not going to like me. Thank you. What do you have to do?
Long division.
So if the degree on top is bigger, if the degree on top is the same, you have to do long division to separate it so you can integrate it. This is no big deal. In fact, you could write 4x squared plus 3 to make yourself feel better. How many times does 4x squared go into 8x squared? 2. And 2 times 4x squared is 8x squared, and 2 times 3 is 6. Subtract. What's the remainder? This one's really important. Yeah, to get the right answer. That means when I come back here, I can write it this way. 2, that's easy to integrate. Subtract, because we're subtracting. All right. Now, can I integrate it after I did long division? I'm telling you, the AP exam thinks that calculus students don't remember how to do this. The last year or two, they sent it out to all calc teachers that are going to put long division in the AP exam, and they're going to make you complete the square. We'll do questions like that too later in this unit, where you have to complete the square to be able to do something. I know. So it's just going to be a point of emphasis, and we'll practice it, so it won't be a big deal. So, what is the integration of 2? 2x. How do I integrate 6 over? So do you see the constant? 3 plus, this is arc tangent. So on the side, I am going to write down what a equals. Just for the second fraction. What does a equal? The square root of 3, because you are a rule follower. U, the square root of 4x squared. And u prime. 2. What number do I have here? So, I'm going to write it properly. I've already integrated 1, so I'm going to let it go. You can separate the integration into the, if you have adding or subtracting, you could just do each one separately and put it together. So, what I want in the numerator is 2x. What I have is, not 2x, sorry, what I want in the numerator is 2. What was there was 6. What number in front would make it equivalent? Good, because 3 times 2 means it's still the same, right? Okay, now we're ready to integrate. So we have 2x, you have the negative 3 times, now what is the rule for tangent? Start with 1 over a. That would be 1 over root 3. Arc tan. What goes inside there is u over a. That's 2x over root 3, and then don't forget the candy.
Has anybody told you that you have neat handwriting?
I have neat handwriting?
Yeah.
Oh, I thought it was going in a different direction. Has anyone told you? No. Number 6. Thank you. I'll go with it. I'll go with the neat handwriting.
Yeah. You can understand.
I know. There's some teachers probably think that their handwriting's all that, and then you can't really read it, even though it's all pretty.
Has like crazy curses.
Does he? He's just showing off.
Oh, yeah.
6.
Looks like he could write the declaration.
I bet. I bet. Oh. I went to private school too. And I don't have to name drop USC.
Not like the church. Yeah, you went to Catholic school. There you go.
I did. I went to Mennonite school with Mr. Hildebrand. Yes, Mennonite. Google it. It's a Christian denomination. Protestant. Catholics didn't like them much back in the day. They had to run away from them, or else they would be like, dead. So, so they had to run around a lot from country to country. But look them up. Mennonite. Another time. Look at this. What is this the form of? Your heart wants to say sine, right? Arc sine. Now, I'm going to tell you why it is not arc sine in a moment. You ready? Let's start it like it's arc sine. That means I'm going to write down what a would equal. That's the square root of 4, which is 2. I'm going to write down u, the square root of x squared, which is x, and then the derivative of u, which is 1, right? The derivative of x is 1. Look at the numerator. It's not a constant, right? Because the numerator is not a constant, I can't manipulate it into arc sine. It is not that. It is also not ln.
Oh, damn. Just bring it up to the top.
You ready? So, x plus 4 is the hook. Well, 4 minus x squared to the negative a half is what u is.
Oh, wait. What am I doing?
Notice that both the fraction and the radical sign I took care of with the negative a half. What's the derivative of 4 minus x squared? That one you could write down. So let's get rid of this now, because that's no good. But if u equals 4, and if you can't do it in your head, why not write it down? What's u prime? 0 minus 2x, right? So what do I do?
That's how it's supposed to be.
Can I just pretend there isn't a plus 4 here? No. So, this is what I can do. The denominator is like a monomial. I can write this as x over the square root of 4 minus x squared plus 4 over the square root of 4 minus x squared. That monomial, like having like one thing on the bottom, can go to both the x and the 4. Now, let's look at the work we did here at the beginning. You see this? That's going to go with the first one. This is some algebra involved. To understand, when you see adding in the numerator, you can separate it into two fractions. It's that large square root sign that ties it all together, where we have one denominator that belongs to both. The first one is what we thought it was. The first one. Remember we did all this work? And the derivative of 4 minus x squared is what? Negative 2x. So this right here, for the first one, what am I going to do with the exponent? Well, first of all, I got to make it look right. Is it negative 2x? So, in order to make it negative 2x, because that's what I need, how do I undo it in front so they stay equivalent? What do I need? Negative a half. Guess what the second one is? That one is arc sine, the second one. Here, let me continue this one. So for the second one, what I scratched out, now I don't want to scratch out, because now a again equals 2, u equals x, and du equals 1. You know the quickest way to make this a 1 in front is that 4 can go where? In front, and now that 4 is really just 1. Now it's set up. Now we can integrate. So here's our answer. You ready? Negative 1/2. I know, crazy, right? The last two, right, remind you you're in calculus. Negative a half goes in front. When you integrate it, look back up here, right? Add 1 to the exponent, and what do you get?
4 minus x squared divided by 2 to the power of 2.5.
That's right. And then you divide by 1/2, which means the same as multiplying times 2. That's the power rule. Plus, do you see the 4 in front? Now, what's the rule for arc sine? Is there that fraction in front of arc sine? No. So we just write down 4 arc sine, but inside is still u over a. What is our u? It's up here. X over 2. And don't forget the candy. So again, the last two kind of reminded you that, hey, we're still in calculus. Oh, number 7. What? That's like foreshadowing. I'm going to remind you that the AP exam, the last 2 years, they're saying that long division, polynomial, and completing the square, they think is a lost skill that calculus students don't think they really need, so that they want to punish you. And they want to torture you and say, I'm going to put questions in that make you do long division, that make you do complete the square, so that skill gets reinforced. So I want to complete the square for this. What does that mean? So when I have a perfect square, I can write it like this, right? When I have a perfect square. So I'm going to teach you how we can write that as a perfect square. So first, when I look at the denominator, I'm only going to look at x squared and 4x. That 8, I'm going to kind of put way off to the side. I don't want the constant a part of it. I don't want to think about the constant. I want to think about x squared plus 4x. Do you want the quickest way to complete the square? Of course you do. So think of this as you did in Algebra 1. This is A, B, and C, like the quadratic formula. You have to take B, and divide it by 2 and square it. By taking B, dividing by 2 and squaring it, it gives you the constant that completes the square. So how did I complete the square in the denominator? You take B, right? B is the linear coefficient, right? What do I do with it? Divide it by 2 and square it. So in this case it would be 4 divided by 2 and square it. What number would that be? 4. So guess what I'm going to add here? Say it. 4. This part, x squared to 4, is a perfect square. Now, I can't just add 4 without subtracting it. Okay, it'd be a different number altogether, right? So because you added 4 to complete the square, what do you still have to do in the denominator? Subtract it so it's balanced out. So you didn't create a new number that wasn't there. Now, x squared plus 4, if you don't know, you can even factor it, right? Like what numbers multiply to 4 and add to 4? What's going to complete the square there? What's going to factor it? 2 and 2. So that's really just x plus 2 squared, and you've completed the square. And then 8 take away 4 is 4. Beautiful. Now we can take the derivative of that. Or now we can integrate it. How do we integrate this? What's in the form of? Notice the constant on top. And it's adding. It's arc tangent. All right. What does A equal? No. 2. What does U equal? X plus 2. And what is U prime? 1. Beautiful. Now be a rule follower. What's the rule for tangent now that it's on a different page? What do we start with? 1 over A, which is 2, arctan. And then what goes inside is U over A, which is x plus 2 over 2. And then don't forget the candy.